very good day everyone. I'm RASYIQIN from Faculty of Health Science, Universiti Kebangsaan, Malaysia. It's my great pleasure to share with you a research entitled Cytotoxicity, Apoptosis and Genotoxicity study of Triphenyltin Dithiocarbamate compound induced on rare childhood leukemia cells. Leukemia is a type of blood cancer causing abnormal and uncontrolled production of immature blood, mostly white blood cells. There are 4 types of leukemia. Among all, acute lymphoblastic leukemia is a type of leukemia that is highest incidence rate in childhood, account for 78% of all leukemia cases. Regimen therapy were given to the patient as a treatment. However, the problem with current drug therapy is it causes severe side effects. The drug have low selectivity to cancer cell. Many cases reported the body of the patient resistant to a drug given, and it also can cause secondary cancer. With that, many research was done to find a drug therapy with better outcome and less negative effect to the patients. Organotin dithiocarbamate is a compound that consists of parentin structure and ligand structure of dithiocarbamate. Previous research showed that this compound have many biological activities such as antimicrobial, antimalarial, anti-cancer, antifungal, anti-inflammatory, and insecticidal activity. So, it was to explore and study the potential of organotin dithiocarbamate compound as it can be developed as biological agent. So, the aim of this study is to evaluate the cytotoxic and genotoxic effect of Triphenyltin Dithiocarbamate compound on rare acute lymphoblastic leukemia cells. And the objective of this study is to determine the cytotoxic effect and selectivity index of Triphenyltin Dithiocarbamate compound on rare cells, to assess the mode of cell death of rare cells treated with Triphenyltin Dithiocarbamate compound, and lastly, to determine the genotoxic effect of Triphenyltin Dithiocarbamate compound on rare cells. For this study, we are using 3 different triphenyltin compounds with different ligand attached. For the cell culture, we are using 2 different cells, which is the acute lymphoblastic leukemia, rare cells, and also Will-to-NS cells that act as a control cell, which is the non-cancerous cell. And for the first objective, we are using WST1 stain to determine the value of IC50. And after getting the value of IC50 from both cells, which is the non-cancerous cell and also the leukemia cells, we can calculate the selectivity index. For the second objective, we are using the NSC5-FIT-CPI stain to determine the mode of cell death. And finally, for the genotoxic study, we are using the alkaline comet assay. Figure 1 shows the graph of rare and Will-to-NS cells viability treated with Triphenyltin Dithiocarbamate compound for 24 hours of treatment. In this study, we are using vincristine as a positive control. In the table summarized, shown the value of IC50 of rare cells and Will-to-NS cells treated with compound 1, 2, 3 and also vincristine. From this table, we can see that compound 2 causes the most toxic effect towards rare cells. According to Koch 2005, the selectivity index that is more than 2 is considered as the drug treated selective towards the cancerous cell. So in this study, we can see that all compounds treated cells cause selective value, which is more than 3. And we can see from this table, the compound 2 causes most selective value towards rare cells. And in this study, we are choosing compound 2 for the last objective, which is the genotoxic effect. For the mode of cell death determination, we can see from the figure A and chart B that majority of the cell population died through apoptosis, specifically towards the late apoptosis. And for the final objective, which is the genotoxic study, we can see from the graph A that the tail moment produced is increasing from 0.5 to 1 hours, and the trend is decreasing starting from 2 hours onwards. This probably due to the DNA repair mechanism have take over the process to repair the damaged DNA. And for the conclusion, all compounds, especially compound 2, show good potential to be developed into anti-leukemia agent due to their potent cytotoxicity and selectivity against Ray cells. However, further study on their mechanism of action are needed to explore the potential of this compound to be developed as anti-leukemia agent. This is the acknowledgement and references.
That's all from me. Thank you for your time and attention.